Okay, moving forward with the idea of reactions, and we're starting with the reaction of alkenes, and we'll be studying the combustion reaction of alkene. So, pretty similar to alkenes, and we'll be over this very quickly. So, let's talk about ethene first. So, ethene reacts with oxygen, okay, and it makes carbon dioxide plus water, right? And what you need to know is that this oxygen needs to be in excess for this reaction to happen. Okay, it needs to be in excess to for this to undergo complete combustion. Okay, else it's going to undergo incomplete combustion, right? So if I were to write the equation for this, it's going to be C2H4 plus O2, and the products are CO2 plus H2O. And this is now the equation for the complete combustion of ethene. Okay, and if I were to balance this equation, so if you remember from alkenes, this was the general equation, right? This was the general equation for figuring out the formula, figuring out actually balancing out the equation. Okay, so this becomes xco2 plus y over 2 h2o. Right, so now if I were to figure out the value of x and y, so here you can see the value of x is 2 and the value of y is 4. So the value of x is 2 and the value of y is 4, and now we can balance out this equation very easily. So C2H4 plus, we need to figure out the number of oxygens. How do we do that? You have got the part here. So y over 4, the value of y is 4. So that's 4 over 4 plus the value of x is 2. So this is 2. And this is O2. So if I were to quickly solve this, this is going to become, if I take the LCM for this is going to become 4 plus 2 multiplied by 4, and this is going to become 12 over 4, and that is going to become 3, right? So the O2 here actually becomes, so let me write this, C2H4 plus, this is 3O2. That's what we just figured out. The value of oxygen is 3, and here the value of x is something that we already know, so which is 2, right? So this is 2CO2, and the value of y, to figure this out, the value of y is 4, so that's 4 over 2 H2O, and that comes as 2 1s 2, 2 2s 4. So this is 2H2O. Okay, so this is the complete equation, complete balanced equation for the combustion of ethene. Okay, and if we were to take one more example, let's say we solve this with the equation. We solve this with for propene. Okay, now propene, that is C3H6, which reacts with oxygen to form carbon dioxide plus water. And again, the same general equation. The value of x is 3 and the value of y is 6. And now what I can just do, I can quickly figure out the values here. So this was y over 4 plus x. So the value of y is 6. So 6 over 4, the value of x is 3. So this is 3. If you take the LCM, so this is 6 plus this is 4, 3, and this comes as 18 over 4. So this is 2, this is 9, and this is your answer. So this is 9 over 2. So oxygens are 9 over 2. Okay, and if I talk about carbon dioxide, so this is basically the same x, and the value of x is 3. So this is 3CO2. And if we talk about here, this is going to be y over 2. So y over 2 is basically 6 over 2. So this is 2 and 3. So this is 3H2. Now, this is the right answer, but in terms of the CAE format, what I would suggest is that you have this, that you remove this fraction. Okay, that you remove this fraction. And what you can simply do is to multiply the whole equation by 2. So what's going to happen? Now, if you multiply this by 2, this is going to become 6H2. Okay, then when you multiply this by this is also going to become, this is also going to become 6CO2. And if I were to multiply this with this, now this will cut down. Okay, so this is 9O2 plus, if you're going to multiply 2 here, so this becomes 2C3H6. Okay, so this is how we balance these equations. Now, another important thing here is that this is something that we're talking about, the complete combustion. One more thing that you guys need to keep in mind in regard with alkenes is that alkenes mostly undergo incomplete combustion. And if I were to write, you won't need to write the equation for that. You just need to know that they mostly undergo incomplete combustion. And the reason behind that is that alkenes have higher percentage by mass. Higher percentage by mass for carbon, right? And what does this mean? So let's say if I talk about alkenes and alkenes. So let's say I take this, then I take this, I take a C2H6, and I take C3H6, and I take C3H8, and I also take C4H8. Now, if you notice here, if I were to notice the ratio of carbon to hydrogen, so in this one you have one carbon, you have one carbon and you have 4 hydrogens. In this one, you have two carbons, and 6 hydrogens. In this one, you have 3 carbons and 8 hydrogens. Okay, but if you were to notice here, now here you have 2 carbons and 4 hydrogens. Here you have 3 carbons and 6 hydrogens, and here you have 4 carbons and 8 hydrogens. So if you compare at this place, for 8 hydrogens, alkenes has 4 carbons, and alkenes on the other side for 8 hydrogens has 3 carbons, which means 1 less carbon. So here the mass of carbon is less, which we can already see that if you notice this one here, for 2 carbons you have 6 hydrogens, or you can say for 6 hydrogens you have 2 carbons, but here for 3 carbons or for 6 hydrogens you have 3 carbons. So, right? So the ratio of carbon to hydrogen is more in alkenes. Here you have a higher number of carbons, right? You have higher number of carbons, which means the percentage by mass of carbon is more. That's why it undergoes incomplete combustion. That's why it requires a lot of oxygen to undergo complete combustion, that it usually falls under incomplete combustion because of the percentage of mass of carbon being higher, right? So this is one thing. And when this happens, when alkene, or you can say when alkenes undergo incomplete combustion, they produce, the products for that are carbon monoxide and carbon. Okay, these two are the products in the incomplete combustion. Okay, and alkenes usually burn with a sootier flame. Now, the sootier flame means they have more of black tiny particles, right? I wish I could show you a visual image of that, but that's not possible right now. But it's more, you can say it has more black fog in in alkenes. And why is that? Because they have high percentage of carbon, and that makes it sootier. Okay, so that's the concept of, or that's the combustion reaction for alkenes.